Welcome to our tutorial on building a professional dashboard with Streamlit. Hey there. In this video, I will give you a step-by-step breakdown on how to build and deploy an awesome data visualization dashboard using Streamlit. I'm Bright, your coach for this session. A dashboard visually displays key performance indicators, KPIs, and metrics in clear, user-friendly interface, helping data analysts and scientists transform raw data into actionable insight for better decision making. In this video, we'll use the Big Mart Sales dataset from Kaggle to build a professional dashboard. Before we start, ensure you've performed Exploratory Data Analysis (EDA) and data cleaning to understand your data and improve its quality. Check out our Pandas Simplified video for a guide on EDA and data cleaning with Pandas. We use the resulting clean data.csv to create our dashboard. Next, we define key metrics for our dashboard. After conducting EDA on the Big Mart Sales dataset, we know it focuses on retail product sales across outlets. Our dashboard's primary purpose is to help retail managers and stakeholders understand products and outlet performance, optimize sales strategies, and make data-driven decisions on pricing, promotion, and inventory. On your screen are key metrics we'll track. With our KPIs defined, next is to select the best charts to visualize them effectively. On your screen, an overview of the visualization we'll use for our Big Mart Sales dashboard. Now, let's dive into the exciting part, coding our dashboard with Streamlit. We shall carry out our project on Visual Studio Code, a free open source code editor. Now, the first thing we do is to create a virtual environment. This is a good coding habit, as it enables us to isolate project-specific dependencies and prevent version conflicts. So next we go to View, select Terminal, so that we get our terminal. And then we say we create a virtual environment like so, and also activate the virtual environment. We create a virtual environment titled Dashboard ENV and activate the virtual environment using Dashboard ENV script activate like so. So if we enter, we have the visual environment activated, dashboard env. So the next thing we do is to create a folder for our project or a directory. We create a directory or a folder, retails_dashboard, using make directory retail_dashboard. Now that we have our retail dashboard folder created, inside our dashboard env visual environment, we enter into that folder using cd retail_dashboard. Next, we will install all the requirements or dependencies we need for this project using pip install. We install Streamlit, Pandas, Plotly, NumPy, and Matplotlib. Next, we use pip show to confirm that all our requirements are in our visual environment. So next we bring our folder to Visual Studio Code by going to File, Open Folder. We'll open the folder, we'll look for our folder. We have a Retail Dashboard folder. So we select it. Next, we create the app.py file, like so. App.py is the main Python script that contains the code for building and running a web application in Streamlit. It is where you define the app's layout, functionality, and interactive element. When you run Streamlit run app.py, Streamlit executes the script and renders the app in a web browser. Next, we import the Streamlit library as st. Next, we'll define setting for the app by giving it a page title and icon that are displayed on the browser. This also defines the page content to be displayed in a wide layout that fits the page width, as well as showing the sidebar in the expanded state. So for a well-structured dashboard interface, we use the block of code like so, where st.setPageConfig configures the page setting the title to Retails Insight Dashboard. We also add an icon. Then we use a wide layout for better visualization and expanding the sidebar by default. The ST title, Retail Insight Dashboard, displays the main title of the dashboard with a chart icon. The title of the dashboard is Retail Insight Dashboard. Then we have the st.write. We welcome this dashboard helps track performance, customers, and revenue in the open and close bracket. Now these adds the brief welcome message describing the dashboard purpose. Next, we'll create another file. Let's call it utils.py in the same folder as the app.py. Now this utils.py contains code that enables loading the CSV dataset for use in Streamlit dashboard. It basically contains a code that imports the Pandas library and defines a function to load the cleandata.csv dataset. Now, if we take a look at the block of code here, we'll have the first of line that says import pandas as PD. This imports the Pandas library for data manipulation and analysis. Then we have the function defload data with the argument path. Now this defines a function named load data that takes a file path as import. Now we have the last line of code there, return pd.read CSV path. This reads a CSV file from the specific path using pandas and return it as a data frame. Now we'll go back to the app.py file and load this or import this load data function from this utils by like so. So in the app.py file, we have from utils import load data. In the app file, we have this set of code for data loading. The @stCatchData is a Streamlit decorator that catches the getData function output, improving performance by avoiding repeated data loading. The getData function loads the dataset. The return load data with the folder and the cleandata CSV file. That is the data folder and the cleandata CSV file as an argument calls the load data function imported from the utils.py file. Read the clean data CSV from the data folder and return it as a pandas data frame. The getData function assigned to df loads the data into a data frame named df using catched getData function. Now the df assigned to dff creates a separate alias dff for the data frame for future filtered version of df while preserving the original. Next, we create the data folder and store the clean data CSV inside. Next, we create the Streamlit folder and in it the config.tol file, our Streamlit configuration file. The Streamlit configuration file defines the custom theme for our dashboard. Theme declares the start of the theme configuration section, while base light sets the base theme to light mode. We are using the light background here. We have the primary color, which defines the primary accent color. We also have the background color that sets the main background color to a light gray for the dashboard. We have the secondary background color, which specifies a slightly darker gray for secondary elements like sidebars or panel. We have the text color, which sets the text color to a dark gray for readability. Then we have the font, where we use sans serif. We can use the st.markdown to display formatted text section in the dashboard. Here, the st.markdown renders the text within triple quotes as markdown, allowing formatted text like bold, bullet points to be displayed on the Streamlit dashboard. Polish applied displays a bold header showing enhancement when made to the dashboard. Determine via indicates that the dashboard visuals is customized. Catching for faster downloads or faster reload highlights the use of Streamlit decorator at catch data for catching data, improving performance, and reducing reload time. We also have consistent spacing, emojis, and concise title, which indicate consistent formatting, including spacing, clear and concise title for better user experience. We also have footers with ownership and version, etc. Now we will create another file, plot.py, where we will have our custom functions for every chart and KPI in our dashboard. Each function returns a ready-to-embed plotly figure for a KPI value styled for dashboards. We will also import the necessary libraries. Okay, so let's make the background a light background by setting default template and assigning it to plotly_white. Then we create a function, def, let's say, style, def style fig, that takes in an argument fig, which is supposed to style. That's the plotly figure, which the function is made to style, and then it takes another argument, an optional title. Let's assign it to none. And then a height with pixels, say 360. Now what this style fig function does is to ensure all charts have a consistent professional look with customized title, margins, legends, and theme. If you're feeling stuck, we've got a video that breaks down Python function in a super simple way, titled Python Function Simplified. Take a few minutes to watch it and you'll be a pro at understanding how these functions and the ones we'll build later work like a champ. Now we create another function that ensures the data frame contains all required columns, throwing an error if any are missing. So let's define our function. Let's say ensure call for the data frame df. Let's say pd dots. We go back to the app.py file to create our KPI cards. That is the KPI cards. We create variables C1, C2, C3, C4 and assign st.column4 to it. This enables us to create 4 equal width columns for displaying KPI metrics, like so. Then we say KPI, the KPI of total sales, we assign it to the variable total, and then KPI AVG for average sales by item, we assign it to AVG. Total gets total sales from the data frame, while AVG computes average sales per item. We also do the same for the variable best cat, with KPI highest selling categories assigned to it, and best out with KPI best outlet assigned to it. Best cat identifies the top selling product categories and its sales, returning it as a dictionary with category and total sales as keys. Best out identifies the best performing outlet, returning a dictionary with outlet and total sales as keys. To display total sales in the first column as a formatted number, and also display average sales per item in the second column. This time we format it to 2 decimal places. We say C1.metric, open and close bracket, total sales, and elf total ... like that. We then calculate the top category sales as a percentage of total sales and assign it to cat share. This is defaulted to 0 if total is 0. Then we display the top category name and its shares of total sales in the third column like so. We do similar thing by using outshare to calculate the best outlet sales as a percentage of total sales, defaulting to 0 if total is 0, and then display the best outlet and its share of total sales in the fourth column like so. We use delta to enrich KPI cards and show proportional impact of the top category and outlet. Now for the charts, we say st.subheader bracket and trends to add a subheader for the trend section. Then we say st.plotly underscore chart and feed sales trend with the dataset DFF. Now the data column is set at none and the frequency is set at M, which is monthly. This will display a plotly chart showing trends in a monthly frequency. We initially removed the date column at the time of cleaning this dataset. So go to Kaggle.com and then use the Big Mart Sales dataset, clean it, but this time return the date and then see how this section is transformed. Let's go back to our plots.py file. We had already created an ensure calls function like you see here, which takes 2 parameters, df, which must be a data frame as type hinted here, and calls, which is a list of column names. The purpose of this function is to ensure or check if the pandas data frame contains all required columns. You have the list comprehension, which loops through C in columns, that is, in calls rather, which is the columns of course. If C is not present, it is added to the missing list. So the variable missing is a list that contains all required columns that is not found in the data frame, and then it raises an error. Next, we create a function to calculate the total sales from data frame, like so. We define the function def KPI total sales. It takes 1 parameter, df, which we ensure is a data frame, like so. And to ensure it returns a float, we use the docstring to describe the purpose of the function, which is to sum all sales in items outlets sales column. We call the ensure column function we created earlier to verify the data frame has the item outlet sales column. If not, it raises a value error. The return float converts items outlet sales to numeric value, handles non-numeric data by converting it to not a number, sums them and return the value as a float. To calculate the average sales per item from the data frame, again we define a function, def, this time KPI average sales per item. Now the df takes in the parameter, which is a data frame. We use pd.dataframe to ensure that this parameter takes only a data frame. And then this float ensure the function returns a float. The docstring average sales per row or item describe the purpose of the function, which is to calculate the mean of item outlet sales across all rows or items. The ensure call is again called to verify that item outlet sales exist in the data frame, else its value error is raised. Next, item outlet sales is converted to a numeric value, coercing non-numeric values to not a number, and then assigned to S. We use the mean method to compute the mean or average of the value of S, and then the float function ensures the result is a float. To identify the top selling product category by total sales, we define a function like so, the KPI, highest selling categories, and then the DF ensure it's a data frame. Now we have the cat call, which defaults to item type, which is the product category column. And we ensure that this function returns a dictionary. The ensure call function we created earlier is called again, this time to ensure that item outlet sales is in the data frame and to select the category column. We group rows by category using group by method. Sum the sales per category with the sum method and use the sort method to sort from highest to the lowest and then assign to G. If G is empty, that is no data available to return. Return no category and 0 cells. Otherwise, pick the top category. That is the category at G index 0 and return both its name and total sales in a dictionary. To find the outlet with the highest total sales, we define the function def KPI best outlet with the parameter which is our data frame and then which returns a dictionary. The function returns a dictionary. Now we have a description of the purpose of the function best performing outlet. We create a variable outlet call and then we choose which column to group by determining if outlet identifier exists in that column. If it doesn't, we default to outlet type. We call the ensure call function again to ensure the data frame has both sales and the chosen outlet column. We group data by outlet, sum sales for each outlet, sort from highest to lowest using sum and sort method respectively, and then assign to G. If G is empty, return no data and sales to be 0. Else pick the top performing outlet and return a dictionary with its name and total sale. Okay, now for the sales trend chart, we will define a function like so. Def fig sales trend. It takes parameter df, which will ensure it's a data frame, and then takes another parameter date column, which is an optional date column parameter, which is also a string and is defaulted to none if no dot column is provided. We have another parameter, month, which is a string and mapped to frequency. Now the ensure column that we've also always used, check that the data frame has sales data. And next we have PD to numeric, which converts the item outlet sales to numeric, coercing non-numeric to not a number, and then assign it to S. If date call and date call in DF columns, checks if a date call is provided and exists in the data frame. If so, convert the specific or specified date call to date time, coercing invalid date to not a time, and then we assign it to DT. So next we create a data frame with DT, which is now date time, and S, which is sales. We drop rows with invalid dates, grouped by frequency, which is monthly, sum sales, reset index, and then rename sales to total sales. Next, we create a plotly line chart with DT, that is date time, on the x-axis, total sales on the y-axis, and markers on data points, which is assigned to fig. Next, we return the slide figure with a title indicating the time frequency. This will be executed if there is a date column in your data. So in the data that we have here, this part of the code will not be executed. But during the time of cleaning our data, we removed the date time. So if no date time column exists, check if outlet establishment exists. So the code checks if outlet establishment exists. If it does, use outlet establishment year as a numeric column Y arrow. Drop invalid rows, group by year, sum sales, and name the result total sales. Then create a line chart with years on the x-axis and total sales on the y-axis with markers. Finally, style the figure with the title total sales by outlet establishment year and return it. But if no date call nor outlet establishment year exists, as in the case with our data here, now create a data frame with index IDX and sales, group by index, sum sales, and return and rename to total sales. Now here we create a line charts with row indices on the x-axis and total sales on the y-axis with markers. Then we'll set the x-axis title to indicate no date column found. Style the figure with the titles, sales trend, index order, and return it. Okay, let's go back to our apps.py file. On that chart, we see ST subheader, which adds a section titled Trends in the dashboard. Inside the ST Plotly chart, we see Fig Sales Trend function called to generate the sales trend line charts from the function, which is now displayed inside the Streamlit app scale to fit the page. We use the ST Plotly chart, use container with true to achieve this, and now define a function to plot the distribution of product price. We say df fig MROP distribution with the df parameter that should be the data frame and beans mapped to integer 30. We show quantile with bool assigned to true. We are using 30 numbers of histogram bin and showing quantile to be true to draw vertical lines as quantile, median, and Q3. We call the ensure call functions which ensure the data frame has the required item MRP column. We create a Plotly histogram with px.histogram of item MRP with the specified number of bins and 90% opacity for visibility. Fig.update y-axis. Title assigned to count labels the y-axis as count. That is the number of product per price bin. The next line check if quantile should be shown, which is true, and if item MRP has a non-null value. Then compute the 25th, 50th, and 75th percentiles of item MRP and store them as a dictionary. Next, define labels for quantile lines like Q1 for 25%, median for 50%, and Q3 for 75%. Next, we iterate over the quantile value and their corresponding value in item MRP. Add a dotted vertical lines at each quantile value with 60% opacity, labeled with names such as Q1 at the top. Finally, style the figure with title. With title sales distribution by item MRP with printing landscape in bracket, and then return it. We go back to our app.py file to display the Plotly histogram from the function fig MRP distribution like so. st.subheader pricing to add a subheading in the dashboard. st.plotly chart fig MRP distribution displays the price distribution histogram created by fig MRP distribution. We use container width assigned to true ensure the chart expands to the full width of the dashboard container. Back to our Plotly file, we will create a helper function and create charting functions that use it. So we define the helper function def bar series, dfbd data frame, group call map to string, and top n, which is either an integer or none, and then horizontal defaulted to true. This takes a data frame df, a column group call to group by, an optional top n to limit results, and horizontal to be true or false to control bar orientation. But here it is defaulted to true. Our ensure call functions ensure that item outlet sales and the column to group by exist. Next, we group the data by group call. Sum up sales, that is item outlet sales for each group. Sort group in descending order of sales. Reset index, renaming sales to total sales. All this is then assigned to G. Next, we check if top n is specified, that is, it is not known. ghead.head top n limits the data frame to the top, that is top n rows if specified. To preserve sort order, we create a list with the variable order of group call values as string. If horizontal, checks if the chart should be horizontal. Fig is a horizontal bar created with px.bar with total sales on the x-axis, group call on the y-axis, preserving order and labeling sales. X. Execute if the chart is vertical. Fig here is a vertical bar with group call on x-axis. Total sales on y-axis. Preserving order and labeling sales. Then return the plotly bar chart. To create the first charting function, we say diff fig sales by item type. We have df that takes the data frame, the top n parameter, and then we'll say fig. We'll assign, which is assigned bar series df. This calls the bar series helper function. Grouping cells by item type. We use horizontal bars, so horizontal is assigned to true. Pass the result fig, true style fig, and return the figure. We tie to total sales by item. To create the second charting function, we say the fig sales by outlet type that takes in the parameter, the data frame. Now we have the bar series function assigned to fig. This calls the helper function bar series. Grouping sales by outlet type. Here we use vertical bars, so horizontal is assigned to false. The resulting fig is passed through style fig. Formatted and returned with tie to total sales by outlet type. We do similar thing with the third chart, where we are grouping by outlet size using a vertical bar. We go back to our app.py file to display charts, where we have the st subheader with title comparison. This adds a section titled comparison. To split the layout into two columns, we'll have column 1, column 2 variables with st.column assigned to these two variables, where column 1 in the left display the bar chart of sales by item, and column 2 in the right display the bar chart of sales by outlet type, both in the first row. In the second row, we'll do the same thing with column 4, column 3, column 4 variables with st column 2 assigned to it. This is to enable us accommodate the sales by outlet size, leaving the fourth column empty. You can add a fourth chart, maybe sales by outlet location, in this fourth column. We apply the same principle to create functions for our pie donut, scatter plot, box plots, and heat map charts inside the plots.py file, and then display them in our app using xt.plotly charts in the app.py file. To make things easier for you, a zip file containing the complete project code is available in the description of this video. Feel free to download it and follow along. If you find the function a little challenging, don't worry. Check out our video, Python Function Simplified, where we break down function creation step by step with plenty of examples. After watching, you'll be well on your way to become a pro. Make sure to import the plots.py model into your app.py file. Next, in VS Code, go to View. Click Terminal. Confirm you're inside your virtual environment, and activate it if you're not. Then navigate to your project directory and run Streamlit run app.py. Voila, your Retail Insight dashboard is live on your local machine. Take a look at the polish we've applied. The total sales of 18,591,125. The average sales by item. The top category and best outlet. The trends and comparison charts. You also notice we left the fourth column empty. You can easily add your own chart there. The rest of the visual complete a professional looking dashboard built in just a few simple steps. In our next video, we'll show you how to deploy your dashboard live on the internet with Streamlit and GitHub, so clients or the whole world can access it via a link. Make your dashboard fully interactive for a better user experience. If you found this helpful, don't forget to like, subscribe, and share with your friends. Get a question or suggestion, drop it in the comment. I would love to hear from you. Thanks for watching. Keep learning and have an awesome day.